Awesome. All right. Welcome to OCWG meeting number 25. 25. We're a quarter of the way to triple digits. Um, yes. So things I wanted to talk about today, 1.0 release candidate slash candidate recommendation, I guess is what it's called. And the other thing is I'd like to talk about my talk at local first conf and kind of share what I'm thinking about showing off, get your feedback, and kind of yeah, I think those are the two main ones. But I noticed we had some other stuff that was brought up. Sounds like Max and Michael, you guys talked about some stuff last time. Um, yeah, what do you guys want to talk about?
Also, Aaron's PR. PR.
Oh yes, that's right. I was going to say there was a PR out there. That's right. We should talk about buffers.
Yeah.
Here we are. All right.
So in the last meetup we had, we discovered that we are still a bit weak on nested canvases. At least it's not clearly stated. So right now we have two ways. One is to explicitly include a resource, which is an OCIF file, which probably should work somehow because it's all spec'd, but it's not clearly defined how exactly the coordinate systems play together or how that works. Or one could use the extension by Michael, which is maybe not needed or maybe is needed.
Got it.
And while we are at that, I discovered that we have this nice scale property in our nodes. And in my mind, it's not completely clear what exactly this scale property is supposed to do, which is also related to nesting coordinate systems, I guess. So I think Aaron is someone who can educate us on this. So we have already this. So right now, all positions are global positions. That's why having floating point numbers is quite crucial. Otherwise, you couldn't express much. But even with floating point numbers, at a certain zoom limit, you hit limits of floating points, at least floating points on a machine. I mean, JSON allows arbitrary precision floating point numbers, but CPUs don't. So
We should work with the assumption that there are some kind of floats.
yeah,
Doubles are like I stated that it's usually doubles the vast majority, and that's like the best case scenario. In practice, a lot of places will import that as 32-bit floats, and that's even worse.
yeah, even doubles don't really solve it. So a colleague of mine working on this infinite zooming canvas, infinity maps, he also states that for an implementation you need something like scale factors. And we have them already. They're just under documented. So maybe we could start with a scale factor. I think you brought it up and we just typed in, yeah, we have scale factors now. But how exactly are scale factors supposed to work right now? Maybe we can extend from there. So if a node has a scale factor of, let's say, 10, 10, what is supposed to happen?
Before we jump into that topic, do you guys mind if we like rank order these? Because
Collect.
I'm worried we're gonna run out of
Yeah.
time. And I
Okay,
think
what else do we have?
yeah, here's what I've got on the screen. So we
Yeah,
got buffers,
yeah.
candidate recommendation, local first comp talk, nested canvases, and
Okay, so I
scale
would just
property.
suggest to swap 4 and 5 because nested canvas is more based on scale factors somehow, maybe.
Okay, gotcha. Solving scale properties might help.
Max
Yeah,
also
yeah,
mentioned the like coordinate system, with the global coordinates and such, and then maybe that was meant to be included in the scale property discussion,
yeah, yeah. That's fine. Yeah,
or maybe it was intended to be included in the nested canvas. I don't know. What is it's related to that, yeah.
but we have global coordinates. I think there's no. no real discussion on that.
Oh, okay, I see. Yeah.
Yeah. So the thing about global coordinates is all coordinates are relative to something. So when I see like in the spec global coordinates, the only way that I can really interpret that as an implementer is that these coordinates are relative to the root of the document, right?
Hmm.
So if you were to select your imported OCIF document and move it, that should move everything in it. You shouldn't leave behind all the nodes, you know. That would be really weird. Um, so I expect that it's always relative to the root of the document. But
But
that means
our
that,
document has no explicitly defined root. So we should state that the implicit document root is at 0, 0, or
well, that yeah,
I think that's stated
it's
in the spec.
implicit, I guess. Yeah, it's every coordinate system is relative to the zero or vector, right? You know,
yeah,
Yeah.
that's like what it means to be a vector.
Origin. Yeah.
That doesn't need to be. Yeah, we state like that the origin is the top left corner of the canvas, which helps people know that it gets positive moving to the right and moving down, but
Yeah.
the fact that there is an origin at 0 is kind of implicit in every coordinate system ever.
yeah. So now it gets interesting if we add scale. But Jess, you wanted to go in another order through the discussion,
I
so
I would prefer to, yeah, if you guys don't
that's
mind.
fine.
Yeah, I'd prefer to get to that one later. I know that like it's juicy and it's right there. And we were all just thinking about it. So,
So let's
um,
start at the top.
whoa, what happened? We lost some content. That was strange.
I think it looks good.
Huh.
Yeah.
Okay, that's tldraw.com fail. Yeah, I had started. Okay, so yes, let's time box this discussion to like 20 minutes, buffers and archive bundles. So we don't, because I think it's possible we could spend the whole time on this one as well. Um, maybe 30 minutes. We'll see. But I do want to make sure we talk about candidate recommendation. Actually, do you guys mind if we talk about if we bump buffers down to below the candidate recommendation and
You
local
can
first
bump
contact?
buffers as much as you want. I'm at no rush.
Okay, because so there is some timing stuff with local first conf talk. So May 28th, in Berlin, at local first conf, there is going, I have a talk spot that I said I was going to talk about application interop and file formats. I don't have a talk title yet, so I can kind of change the title around however I want. But I have a full 25 minutes to talk about whatever I would like to talk about. And here's what I have for an outline so far. I was sharing this at the beginning of the meeting. Uh, what I'd like to do, oh, I guess one other piece of history that's kind of interesting is at Local First Conf last year is where we wrote the first version of like the first documentation, the first version of the spec. Like version 0.1 was Orion Reed and I sitting at a table outside of Local First Conf and saying like, this can't be that hard. How hard can this be? Like we need one of these. And I think we had been chatting slightly before that on Twitter about it. So we knew we wanted to work on it and we knew we were going to both be at a conference. So we sat down and like wrote the first version there. So it'd be kind of fun at Local First Conf 1 year later to say, here's a picture of Orion and I writing last year, like 0.1, and today's like the 1.0. We're announcing the 1.0 candidate recommendation. It'd be kind of fun. But the goal of the talk is to talk about application interop. You guys might be familiar with local first software, you might not, but the idea is, that the when applications are running on your local machine, you do have the data on your local device, but you don't always have the data in a way that it actually makes sense to access it. So it could be that is usually because they're stored in. I can't help you right now, like. Um, So that might be because yeah, a lot of times that's just like if it's a local first app that's in the browser, It's stored in some esoteric database. It's locked inside the browser. Like the user can't get to the data in any way that's meaningful. And so the encouragement here is for local first app developers, at least offer exports to flat file formats. Like that's like level one, is like let people get the data out of your application in some file format that's not your fancy little JSON file, or binary, God forbid, a buffer, for example. Kidding. But yeah, so we'll talk about Markdown. I'll talk about some different things that export enables. So, you can use Markdown. There's like these really fun dialects of Markdown for using them for like calendars and to-do systems. I'm going to show a little demo of that I built of turning for a tool that I use that turns a Markdown to-do list into a Kanban board. And you can edit it both ways. Like you can drag the cards around and it updates their status. And that's enabled because Obsidian like writes to the file. And then I was going to make the comment of like, look for existing file formats that you can support rather than like coming up with an arbitrary one yourself. But sometimes one doesn't exist yet, and you have to come up with one yourself. And so that would be the intro to like OCWG. But guess what? We need a thing called OCIF, and I'll talk a little bit about that. I don't know what the fun, like maybe the most basic demo is showing like a super basic OCIF file and showing that like opened in 3 different things, maybe like maybe showing an SVG export, maybe showing it in SVG, showing it in Obsidian Canvas, showing it in TL Draw or something. I don't know. But I need some demo to like introduce to motivate OCIF. And then the next thing would be the next level up from just like manual export is continuous export. It's read only, but at least you're always projecting your internal file format into some file that people can write readers on top of to represent that file in some different ways. So one good example of this that's kind of cool is Linear. You can link Linear to a Google Sheet, and it will automatically keep that Google Sheet up to date with all of the issues and all of their status and all of their columns and all that kind of stuff in your Linear instance. So it's read only. If you like make a change in the Google Sheet, then like Linear on the next write will like overwrite that change. But you can build cool stuff on top of Google Sheets. Like you can build your own charts. You could build your own like dashboards on top of that sheet that refer to cells in that sheet. Go ahead, Max. Yeah.
But that's not local. Google Sheets is not a local thing. Would be nice to have an example with a local export.
If you have one, I'd love to hear it. I think Linear is local first, which is cool. But I agree it'd be nice to have another one.
I have an example that might qualify as this.
Yeah, sure.
In Godot engine, so Godot can import GLTF files, but users don't always have GLTF files. Sometimes they have Blender files, and they have to like go through an extra step to export it as GLTF every time they make a change. So to make that workflow easier, Godot has integration for Blender, where Godot will just detect when a Blender file changes, and then literally you give it the path to the Blender executable. It will run Blender, export it for you, then it will save that GLTF, and it will import that GLTF, and it will pretend that is the Blend file.
Wow, that's robust.
That's pretty nice. Yeah, that's exactly what you want.
I mean, from my opinion, we could basically use OCIF like demos the rest of the way through. It's kind of like after introducing it, like it doesn't have to be linear to Google Sheets. So another example could be, having TLDraw continuously export an OCIF file, which we then like render to SVG or something else. I don't know. I'll have to think more about like what are some cool demos, some cool things we could do with OCIF. But that's like the next level is continuously export. Then the really cool one is like full source of truth, like read write, where if we had an OCIF file that's sitting on, so this one I was hoping to maybe use Obsidian Canvas and like maybe a local running version of TLDraw. And so it's watching via the file system API that local OCIF file and also updating that local OCIF file. Obviously, if you write in both places at the same time, problems. But it would be cool to like show Obsidian Canvas on one side, editing it on TLDraw on the other, and then go to Obsidian Canvas on the other side and it updates in TLDraw. Open to using other tools here. Doesn't have to be these two. It's just I know that Obsidian Canvas already supports file read and write, so I don't have to implement anything there. We just have to do the Obsidian. We have to have some like watcher that's watching the file, the OCIF file, and then continually writing out the JSON Canvas file so that Obsidian Canvas can pick it up. How I'll do local TL draw, I'm not exactly sure. You guys have thoughts on this one?
I think it's doable. Local TLR shouldn't be a big problem. I think you can use their package.
I think so. Yeah, I think it's. I think it should be pretty easy. All right, and then the final thing I thought would be kind of cool is talking about the other benefit of robust file formats is you can actually ask AI to write out those file formats, and AI, if you have a well-defined spec, then AI actually does a reasonably good job of actually writing things. So I was thinking about maybe even having like a model context protocol tool that can write OCIF. And so then I could show it inside of a chat with like Claude or something like that, where you're doing some chat and you're saying, hey, can you write out a couple of, and it like writes out these OCIF files for you, and then you can open them up. Again, I'll have to work on making the thing cool, but just giving, oh, I had another thought about this, by the way, over the weekend of, it would be really cool to have a benchmark for AI's ability to generate canvases. So you may have seen a couple people like ask AIs, anytime a new AI comes out, they ask it to generate an SVG. Like there's one guy that does an SVG of a penguin riding a bicycle. I think that's Simon Willison. Every single time, generate me an SVG of a penguin riding a bike. That's like his benchmark. It's not a robust benchmark, but every single time he's seen it like get better. I wonder if we could do the same thing to like basically, yeah, to promote. There'd be this is like a side project, not necessarily. It's sort of OCIF or OCWG related, but having a benchmark that's like how well, and we could basically have a gold standards of given this prompt, here's what you should be able to generate. Like, and then we could do some form of scoring of like how close has it gotten to that particular bench. Anyway, that was another random thought, but I think the final demo would be AI and writing OCIF. So
We have a basic OCIF generator with AI already. So
yeah,
you can look
see,
at
I was
that.
I was trying to figure out how I could get someone else to build all of my demos, and then I just have to worry about giving the talk. I just have to make slides, and Michael will make an awesome demo of AI writing OCIF, and Max will do another demo, and Aaron will do another one, and I'll just make awesome slides and get up there and talk.
You make them manually without AI? Jess, what's happening?
I don't believe that.
All right, so I think the big takeaway here is what do we want to do for a candidate recommendation, assuming that May 28th is our target date for announcing that candidate recommendation. So I think that would lead to my next discussion point. Anybody have thoughts or ideas on that?
Yeah, so I looked up the W3C process on that, and they basically write up a spec, let it simmer for a while, then invite people to give feedback, then improve the spec, and then say, now it's a candidate recommendation. We solved all open to-dos. Everything seems to be clear to us now, and now we invite people not to give feedback on the text, but actually try to use it. That's candidate recommendation status. People, please implement it now. It seems ready. We could say we are almost at that step, and then maybe look at all open issues and to-dos to verify that things are looking good. Today, I asked Gemini to give me feedback on the spec and look for inconsistencies. It found only minor things. That's fine. And I added them in the PR already. So overall, the spec text seems to be rather good. Yeah, maybe the biggest open issue in my mind is this using coordinate systems to make that more precise and deal with the nesting then in turn. Do you guys see other unclear parts about the spec? Do you have something you know about right now?
I don't personally. I mean, we probably should talk about buffers because that would be a big. Actually, I
This,
think in general, having an idea of how we're going to handle archiving, because that was the
yeah,
topic that Aaron post brought up for me of like, oh yeah, we probably should at least have an opinion on how you bundle together assets that are not in like linear, that are not embedded in the file itself.
Yeah.
Um,
And it
and
could
so
always be like done as an extension too, especially if it's not super common to need this for Canvas apps.
yeah,
Yeah. Well,
yeah,
on
oh,
this
sorry.
note, I want to mention that it is really important to have plenty of like test assets and actual like compliance testing done to make sure that implementations are following things and to be precise enough where it's like impossible for anybody to get things wrong. Because there have been many cases of standards doing things wrong and then like it's like a huge mess trying to clean that up because
right.
some tools are exporting things for compatibility with this thing that does it wrong. So then the exporter is doing it wrong. And then you try to like submit a PR to the exporter to fix it. And it's like, no, we're already doing it this way for this thing. And if we'll break compatibility with that thing. This was a big problem with the KHR Lights extension for GLTF. The light unit was not being respected properly because of a bunch of confusion. So like the specs said it was lumens or candela depending on the type of light, and the example files shipped with lights that had like an intensity of like 1 and 10. But like with lumens, you're not going to be able to see that. It's too dim. You need like 10,000 lumens to be able to see anything, not 10.
Mhm.
And Blender was exporting watts. So that's also completely different. So we had the spec and the examples in the Blender implementation, which by the way was maintained, it is maintained by Chronos. These three things that were all made by Chronos, completely different, and they did not work with each other at all.
Uh,
Ouch.
yeah, no, that
Interesting.
was what I was going to say as well. Aaron, is I don't see any real significant open issues with the spec itself, but I see a huge gap that you could drive a truck through in terms of tooling, testing, like verification. And I would really want to at least provide like a TS library with some tests, and that kind of thing before we get to candidate recommendation. Now, none of that work is sexy, like it's just grunt work. But I also think AI could probably do a bunch of that work for us. And so uh, I actually have an open PR that we could look at, not in this meeting, but y'all could look at afterwards, that basically lays out how the monorepo should be designed, that the OCIF tools thing of like, how should we solve the library problem? How should the CLI work? And then it like lays out an implementation plan. And my plan is to go through this with Gemini and have it like build each one of these phases. And the important thing is like having it be test driven at each stage. Like, here's a bunch of examples, and have Gemini generate the examples and then like curate those. So curating more of the test suite is kind of my thinking on that, but we'll definitely would love support in that area as well. Um,
By the way, just really quick with the lights thing,
yeah,
this is actually like years old, but still hasn't been resolved yet because Chronos hasn't provided correct examples for us to go off.
I mean, I mean, Markdown is another example where the spec was not fully fleshed out when John Gruber released it, and there's all sorts of edge casey things in Markdown that like don't exactly work.
The
But I
amount of
think,
variance in Markdown is so frustrating. And
yeah,
I hate how it's like some places use the underscore for like italics and some places use it for underline. The underline makes sense, but then like the original thing was italics, but
yep,
there's
crazy.
two ways to do unordered lists with the asterisk and the dash.
Yep. And also the spacing between lists. You can have wide space lists and non-wide space lists. And yeah, not everybody implements either one of those. It's weird. Okay. So anything else from terms of candidate recommendation? Like if we had, for example, an OCIF tools repo, and that OCIF tools repo had a library, a TS library that you could use as sort of when you're parsing an OCIF file, you could bring it into sort of memory and then have like well-typed things. You could validate that file, and then you could also import and export to just a few formats. Like we don't need every format on the planet, but like TLDraw, SVG, Obsidian Canvas. Maybe that's our first three. Would that be sufficient in terms of tooling? And assume that there are tests of like there's 20 different, 30 different OCIF files, maybe more, that we can then run a test suite against. And then maybe a few examples of TLDraw, like the converters are tested as well.
I will note that automated tests are great, but for a lot of these where you need to like verify like visually that they're correct, you are gonna have to have whoever's doing the implementation, part of their job will be to like run this gauntlet of test assets through it and take a look and like see if it matches it. And you need to have screenshots of every test asset too, so that it is clear what it is supposed to look like.
We could potentially set up Playwright infrastructure for that, of like have it do visual diffing between of like, great, you changed this, but now the visual diff is different. But yeah, that would be some significant infra setup.
I would say for candidate recommendation, where we don't have to have all these exporters and importers and helper libraries already. That's part of the candidate recommendation phase to build the tools. To have a validator and tests, yeah, maybe that. But other tools are not a prerequisite for CR status.
Good point. Okay, so you would say have the
validation examples and tests, somehow automate running examples. Is probably enough.
Yeah, that's a great point. Fair enough. I would also say like there's some other logistics stuff that we'd want to do, like other tasks, like update the website, update the README, the org README.
Yeah, on the website, I would propose that we somehow render the spec to HTML and also publish it on the website so that it's not in this little rectangle.
Agreed.
In GitHub, but properly readable.
Yeah. And yeah, I do think more examples, like that's a big one. It'd be great to have running examples. Running in TLDraw, export to CSV, live export to SVG, something. And then yeah, some tests. I like this as an ordered list though, of like most important is to have a validator and some examples, and then tests, and then yeah, most somewhere down here on the end is like tools for other things.
Yeah, this is a good order.
All right. Well, I'll take on the work of, it's already 12:30. We got half the meeting, and we probably should spend time on these open issues. So I'll take on the work of like getting this into GitHub as issues with like a milestone of a CR milestone, and we can debate about what belongs in that milestone and kind of the priority order there.
Cool.
What do you want before the May 28th?
What's that? Say again, Michael first, and then yeah.
What do you want? What do we want before the May the 28th for the candidate recommendation? Because this is already a very extensive list, I think.
Yeah. Tis. What was the question about May 28th though? What do I really want? Is that what you said?
Yeah.
Like an MVP?
The minimal.
Yeah, probably the MVP would be like probably the MVP would be this. It's like update the website with a rendered HTML spec with just what we have today. and just be like, there's a validator, OCIF validator like website. We don't have a library. We haven't set up OCIF tools. We don't have a ton of examples yet, but you can go read the spec. That would be, if that's the only thing that happened, I would still say it's worth it. This is just like sweetening the deal in my mind.
Yeah.
Maybe if I could get one more thing, it'd probably be more like an example or two on the website. Like more examples is probably, in my mind, more important even than validation, because there is a validation website. Like you can do validation. It's not the best to be able to have to do it there and not be able to do it from the CLI or from the library, but it can be done. Whereas I feel like examples are super important for people to understand how the spec actually works.
And the validator can export to SVG and TL draw. Minimal, but it can.
Yep.
Can export a little bit.
Agreed. Yeah, file over app was a major inspiration for what I was working on. OCIF generator, yes, the OCIF generator tool.
So what I was
Thanks.
gonna say a minute ago is that I know you have like a deadline of May 28th here, but my own opinion is that something as important as a standard like this for a file format that should ideally, exist for hundreds of years, should be, carefully thought out with time and not rushed or anything. So if it were me and I'm like just developing it myself, I would spend like a really long time like developing my own implementations and like several things and a validator, and I would do like a lot of development before I even like posted it anywhere for comment, because I would want, even if I had to like repeat a lot of that work, I would want to, make sure it's in a really good state before I present it to people, so that like right off the bat it's pretty good, and then there's a less chance of something bad becoming a standard that plagues people for hundreds of years.
Here. In fact, I'm glad you mentioned the hundreds of years, because the local first principle that I'll be talking about is the long now. That's like one of the 7 principles of the thing, and it's one that is rarely talked about within the context of the local first community, even though it's right there alongside the other 6 principles in the original article. Is there anything that concerns you, Aaron, where you would say like now you can say today that you would be uncomfortable with May 28th, like, and would recommend that we not do a candidate recommendation? And we like, what's the phase before CR, Max? I'm trying to remember.
That was last call, working draft.
Working draft, last call.
Yeah.
I don't know what to call it. I'm not a marketing person, but I would just, do a lot of development while it's in the draft phase. And, uh, hopefully that means that, once you get it out of draft, you can have a pretty seamless, whether it's timely or not, I don't know, but like a pretty smooth transition into release.
Yeah, but candidate recommendation is not a release yet. It's still a kind of draft, but it's the state of draft says now we are looking for implementation feedback, not for text feedback. So
yeah, I think this is the 5 phases, Aaron. And so we're not actually we wouldn't be at a proposed recommendation. We would be at a candidate recommendation. And in reading through these different stages, it feels like we're actually past working draft. Like we do want feedback from other groups, but we're at the point where the way we're going to get good feedback is not it's unlikely that it's going to be someone reading the text of the spec and going, have you thought of X? It's going to be them like trying to implement and discovering like, oh, you guys missed this huge edge case. And so like Max pointed out, which I really appreciate you pointing out, developing the test suite to verify interoperability is what you do during the candidate recommendation phase. And yeah, that's a fair point. And also takes some work off my plate. So thank you for saying that, Max. or some pressure that I was applying to myself, I guess I should say.
Yeah, so I think for me, candidate recommendation is fitting.
All right,
Yeah.
that all makes sense. I do want to. I'm not objecting to the candidate recommendation, but I do want to raise one counterpoint against it,
Okay.
um, which is that when's the last time that we merged in a pull request that changed an existing part of the spec instead of adding onto it? And the answer is today. So to
Yeah.
me, it doesn't feel too stable yet. Like, I mean, it's we could easily make a declaration like, "Oh, we're not going to change things majorly for we're pretty happy with it." But you don't know that.
Yeah. It's true. But I think the goal of the candidate recommendation stage, from what I understand, is actually to still be continually making changes to the spec, but be making them based on implementation experience. And so, yeah, the expectation is that we won't be stopping making changes to the spec right now. You should not treat this as a 1.0. You should go play with it and fiddle with it. It's weird that W3C uses this language that it's like a 1.0 candidate recommendation, but it really is like pre 1.0 the way that we think about it in other software versions. But yeah, you're still openly iterating on it, making changes to the spec on a daily basis, potentially, all the way up until you say like, okay, now it's a proposed recommendation. We're not actually making changes yet. And we're going to leave it open for several weeks or
So obviously we need to verbally explain what we mean with candidate recommendation because not everybody is familiar with W3C processes.
yeah, great point, Max. And I'll do that in the talk. I'll heavily caveat. Um,
It's
while
actually
also like,
funny how
okay.
OMI is up as a part of the W3C, but we have like a completely different system at OMI, so I've never heard of this before.
It's it is a like everything at W3C, it's a recommended process that you can follow if you would like. It's like available to you. Here's a process that you can use, uh, but you don't
That
have to.
Man, these organizations are so big, W3C, Kronos, even
Mhm.
did you know the United Nations has its own metaverse standards organization?
I I definitely did not know that. Um, all right, buffers, archive bundles, etc. Let's spend a few minutes
Yeah,
on that, or I guess let's choose. We've got 20 minutes. These are both probably 20-minute conversations, like
let's
buffers and scale
start with
properties.
archive. Why not? We have it listed above.
Okay.
So to recap, we start with a JSON file and we only refer to external resources. Okay, cool. Then we discover, yeah, okay, sometimes that's not quite standalone. So we want to embed resources. So we take the easiest next step, embed the resources as base 64. That solves already a bunch of problems. We now have a single file. If it's too large, we can zip it and fine. At a certain size, if you have not 3 images in it, but 300, this becomes not nice to manage, not nice to load in an app. It doesn't really scale well. So suddenly you need to find a next way. So then we have these external references. So we have the JSON file, and next to it, we have the image files, which is super nice for a local app because you still have just a JPEG file locally. You can double click it, open it in your local browser. Everything works fine with local files. Just need to make sure that the local references resolve correctly. But now you have a new problem. Now you have a bunch of files. How do you ship all these bunch of files to a friend? You need to somehow have an archive format that somehow defines what needs to be in that file, where in that file, and what exactly is the archive. And then there are maybe 2 routes to take. One is to say we define a native archive bundle, which is very compact, nice, and everything, which is one way, or try to leverage something like a zip file, like what Java does with jar files. So to have a defined archive format based on zip archives, where you basically define the path structure and where to find the OCWG file in that path structure. And then the big problem with zip files is they don't have nice random access. So you can okay-ish read a single file from it. You need to skip through, find the right index, and decompress that one file. That works okay. But if you really want to update one file in that zip bundle, that's not so nice. So if the app usually has everything in memory, and then just the export is done in the archive file, that's fine. If it's usually having some other database somehow for its file and just using the export in the zip file, that's also fine. But if it's really the native format, the zip file, that's probably not a great choice. But as we are export interchange file format designers, maybe we don't have to aim for a native file format because most apps will need their own native file formats anyway. So I guess some kind of zip archive could fulfill our needs, unless I misunderstood some needs from Godot engine.
Mhm.
Yeah, that could certainly work. And having everything stay as files in the zip does let you keep leveraging that URI.
Mhm.
So yeah, that would make sense. Yeah. I had not considered that before, so I haven't really pondered about like entirely what are the upsides and downsides of that compared to just doing it the way GLTF does. Um, but that is a good thought.
So then even in the spec, we could just add a chapter saying, okay, if you want to bundle it up in a zip archive, this is how we define the structure, but everything else about the local file URLs and so on just stays as it is, which I like. And debugging is also nice. Very often I took a zip unarchive utility, opened a jar file, looked into what classes are there, and figure out what's wrong. So it builds on existing tooling.
Mhm.
But I'm not sure how nice it is to use zip files as native containers in the browser. I don't know if there's a JS unzip utility. Not familiar with that.
For me, I would just expect that you could just load the whole thing and then extract it and then like import it into whatever native format you're using, which might just be, you know, an extracted version of the data that's uncompressed of just reading the OCIF data, or it might be a completely different thing that is what your engine uses. So the other consideration here is that um, buffers provide a more general solution for storing just kind of any binary blob of data. So like one example use case is like a PNG image, but there might be data you want to store that isn't like in a well-known file format. So we could still do that in a zip by like pointing it to some file.bin and it's
Mhm.
just unstructured data and you have no clue what's in there. Um, and a buffer would allow you to pack in multiple things into the same thing, um, which is maybe not so important, especially if you know it's a zip. Then to the user, it's presented as a single file, so you don't really even notice that it's multiple files. So when I started working on this, I was working on this in the context of Godot and in G4MF. My ma working on like the GLTF in Godot and then working on my own format, which both like have this need. And I thought, you know what, I should do the same thing for OCIF since I like it's all fresh in my mind. But after like making the PR, like as I was writing the description, I was thinking like, maybe it's actually not really needed because you know, with a 3D model, you have a lot of these blobs of data. In fact, it's mostly going to be these blobs of data for describing like a mesh geometry and vertices and stuff. And with a canvas app, you're mostly going to have geometric shapes and colors and images, and those can either be represented as JSON data in text form, or in the case of images, just as an existing format for the image. So I think the use cases of the buffer is much less. It's certainly much less for Canvas apps than it is for a 3D model. To what extent, I'm not entirely sure, but it would be an argument in favor of going the zip bundle route because that would be like I think a lower friction compared to the dominant use case of we're expecting here, where most things do have a meaningful format in a separate file or just in text form.
Cool. So maybe we explore the zip route first.
I think so. The other benefit that I thought we didn't talk about is being able to export all of my files, like do a live export from my file system to my file system in a file that's not in a folder, sorry, that's not zipped. Then you can do things like, copying the images out of a canvas becomes this like file system level operation, as opposed to like clicking around inside of an infinite canvas to like grab all of the PNGs and JPGs and that kind of stuff. That's kind of cool. And like buffers explicitly don't enable that, right? Because it's just that binary blob of data.
But that last bit only works if we do specify your images should be placed in a folder called images. Right now, we don't have anything like that. We just have URLs.
Yeah, I think what we could do with the zip bundle is not specify it strongly, but like say recommendation. Yeah. Here's a recommended structure, because we also don't know what kinds of files people might want to put on their infinite canvas. That's one of the things about infinite canvases is you don't know all the file types. And some canvases support really weird, wacky file types that you wouldn't think of. And you want to support that as a potential asset. And let them be okay with that. So we can make recommendations, but we can't say like, here's where everything is going to be stored, because we don't know what everything is. So seems like a reasonable thing to explore. Cool, we may do that quickly. Should we talk about so yeah, like I guess
Yeah.
talk about the next one?
I have updated my PR to be a draft so that it's clear that it's not like something we want to merge anytime soon.
Gotcha. Yeah. And are you interested in pursuing that as an extension, Aaron?
Hmm.
I'll let you consider that, but like that would be one way to like morph your PR is like morph
But
it into
if we only have a few buffers for geometries and stuff, which are maybe not that large, I'm not familiar with that, then maybe base 64 is just fast enough.
That's true. And also, like, I expect that for any two-dimensional object in a canvas, the data, like, that kind of data is going to be less than a 3D model anyway. Um, yeah. So
Cool.
I think the another just the single biggest benefit of the zip format, I think, is that it lets you we can kind of implement this zip format without like changing the OCF spec at all, because the OCF spec doesn't. We could just keep using file URIs. The OCF file could just think that it's doing file operations, and like you could very trivially just extract the files and then just say go import this, and then any implementation that doesn't support the zip based can still import those things if you just do one manual unzip. So like it is very convenient. And so would it really be like an OCF extension? It would be more like a format defined on top of OCF.
The
Maybe
latter, yeah.
just a part of the spec that says like, oh hey, you can do this and here's how.
Oh yeah, no, I was actually suggesting, I don't think the SIP bundle needs to be an extension, but I was wondering if you wanted to explore buffers as an extension.
Yeah, for
Have you
that I
answered
could
that?
easily move that to an extension, yeah. Um I am I do wonder what use cases we have in mind for it, because if it is an extension and we're not like requiring it, then we do want to like, we wouldn't use it for things that you could already use the base spec for, because that would be, silly. So
Right.
PNG images should still be as files or as base 64, for example. So I do want to, we do need to think a little bit about like what the use cases are for it to make sure that we design it in a way that's good for that. And to be fair, there's not really that many ways to design it. So Maybe I'm overthinking this, but I like to have use cases when I design things.
Heck yeah. No, that makes sense. All right. You guys, Max and Michael, you guys talked about nested canvases last time. We've been talking about scale properties and floating point precision. Yeah, where do you want to pick up?
Yeah, let's start with scale properties. We have a node has a scale property right now, and I'm not quite sure what it really means. So we have scale is a vector for all dimensions. Let's first start in 2D, and let's say we have a scale factor of 10, 10. So what is now changed?
Hmm.
As a user of a game engine, the concept of scale is very like intuitive to me. So my like immediate thought, even though you mentioned this way earlier, my immediate thought is still, what about this don't you understand? Like I can't really get into the headspace of not understanding it.
Yeah, we have global positions. So every node has a global position anyway. So the scale factor seems irrelevant. No matter what I do there, this node position stay the same, unless I use relative nodes extension, but relative nodes extension only specifies an offset to the position.
So if you keep a node in the same relative position and use scale, then that's going to scale that's going to move the global position. So but it'll change the position that gets serialized in the OCF file. But it doesn't just change the position, it will also scale that node, because if you scale a parent, it also scales the children by that's kind of how the behavior works. So
But
um
only if we also use parent-child, right? Scale without parent-child is sort of
That's
meaningless.
yes. Yes. Well, if you have scale without parent-child, then that only scales that single node because there's no hierarchy. So it would just like if you had like an image resource displayed on that node, it would just make the image 10 times wider and 10 times taller.
But also the node itself. So the dimensions, the node has I think a node has a size. So let's say the node says I'm 1, 1.
Yeah.
And then it says scale 10, 10. So that means it has size 10, 10.
Yes, that'll be the global size. It scales everything about itself.
So the scale affects itself, not just its children, itself.
Yes. It
So,
will affect itself and any children if it has any children, but that's only if you're using the relative node or the parent-child node extension, I mean.
okay, this, as stated like you just did, I don't like because it's different from what we have for the relative node extension. The relative node extension does the following. We have a node positioned here, and we have a node positioned here, both in global absolute coordinates relative to canvas root. And then the relative node extension can say, actually, my coordinates are not random. They have been computed by taking this parent node and adding an offset of 2020 to it. And that's how I arrived once at my global coordinates, which I express redundantly also in my position. So a dump application can just import everything, look at the global coordinates of everything, and just place it there. And then a smart application can say, the user just dragged this one, and I know what relative is, so I can now move this one accordingly and recompute the global properties. So there we have this nice thing of redundancy, and global positions are really global. Can we achieve the same with size, so that size is really just the global size on the global box? But scale somehow helps me to recalculate it in a way.
The other thing that's
Like,
troubling here is like with scale and size as different things is that you end up having, thank you, Brett. You end up having if you want to calculate like overlap or anything like that, like hitboxes and that kind of like collision detection, that kind of thing of like, is there anything at this spot on the canvas? You can't just load position and size and run the calculation. You have to run position, size, and scale, and then do the scale, and then because it's not actually where it also like screws with like human readability of like I'm looking at this and going, it looks like a small 1 by 1 square. And it's like, well, no, because it has the scale factor, I have to like do the math in my head. Like it's not actually a 1 by 1, it's a 10 by 10. So
yeah, maybe we need to distinguish global size and position from local size and position. And
I will say
Hmm.
this is actually like a legitimately good like topic that you're bringing up because my intuitive sense of scale is like derived from the fact that I expect all transforms to be like local relative to the parent, and that's not the case in OKIF with position. So that has a bunch of implications for all other transform properties too. So scale, yeah.
Mm-hmm. Yeah, that's
I mean,
interesting.
this ability to nest scales and transforms is crucial to have a really zoomable app that's not hindered by double precision or floating point precision. But we want somehow both. Ready-made global data
Yeah.
and a
Is
way
it?
to compute it better
So
if needed.
if we wanted to define scale as always like global, then if you like are in an app and you scale something by 1010, does that mean that the app like when it's writing the OKIF file, it should serialize it should save the global position and the global scale of all those nodes to match. So like if you scale the parent nodes, then all the child nodes will also have a global scale of 1010. Would that make sense? Because if position is
The
global, maybe
question is
scale should
good.
be too. And then
I
should the
don't know what
relative
scale
node
really
extension
means.
have should the relative node extension have its own scale property for local scale?
That's what I was thinking. Maybe scale is actually pushed down into the relative node extension. And so,
Maybe, yeah.
and then we don't have this problem of like it's at the global level of like scale only means I can scale these things all together like this, right? Like this is scale. And
Yeah,
I'm scaling, and these are parent-child related to this thing up here. And then we don't have this, yeah, I don't know. That feels right
That's a good
somehow.
direction. Yeah.
Uh,
I have a global size, I have global position, but I give you the formula. Actually, my scale, no, my size was
mhm.
computed by taking the parent and applying a scale transformation. Or maybe we have a relative size similar to a relative position. We also discussed that with Michael last time, where we wanted to be able to express positioning within the parent in like I think what Aaron once demoed, where you can say I'm at 1 1 in the parent, or I'm at 0 0, or at 1 1, or
Mhm.
yeah, the anchors.
0.51. Yeah, and this local positioning is very nice. Just using the parent as a local coordinate system and express your coordinate relative to the parent coordinate system. So the parent has a position that has been arrived, that is known. It has a global position and it has a global size.
Mhm.
That spans a coordinate system in which I can use a local offset and a local position relative from going from 0 to 1. Maybe if the parent has a size that's not square, that's a bit weird. But besides that, I think we are going into a nice direction.
Yeah, this feels good. Like, so yeah, we would the thing to explore, I guess, here is dropping the scale down to the relation level, and what are the implications? It occurred to me while we were thinking about this earlier, and I was thinking about testing and examples and all this kind of stuff, that this feels like one that would be really helpful to iterate with examples and then say, like, show what that actually results in, of like, imagine that you had this, parent that had these children and you modified the scale property. What should happen? Well, we think, I don't know, this feels like a very example driven because it's not super intuitive. Like you have to hold a lot of things in your head to whereas some of our other things, it's like really straightforward what it means because doesn't have like sort of cascading impact. Because there's other things that we would need to think about too, like what happens if this has something inside of it, like this thing has this is this thing is parented by that thing, which also has a scale property, and this has another scale property, and like yeah, there's like some interesting things to think about.
I know we're way past this bridge, and you know, maybe it's way too late for this, but I do want to just bring up again, um, if I was designing this format, I just wouldn't have the global position at all, and I would just have everything be relative to the parent. Um, and that makes things a lot simpler. And to be honest, computing the global transform is not like hard. Like even if you have a dumb app, you could have an importer that like computes these things, and if your like you know your importer already has available to it some library for multiplying transforms together, then you could which is a trivial operation to implement if needed. That could be done in, you know, like a few dozen lines of code. Just like get all the node, get its transform, get the parent, get its transform, multiply it, then keep going iterating through the parents, get their transforms, like it's pretty simple, I would say. So I personally don't see any value of trying to make it easier for dumb apps that can't do this because it's like it's so trivial to me, at least.
Mhm.
Yeah, I disagree a bit because not all apps are using this zooming really a lot. Some apps more or less have one canvas where everything you see is everything you get, and zooming is more, you don't zoom much. And for this app world, having absolute coordinates is just so much easier to debug stuff and see stuff. I think we should have both. And if it's so easy to calculate the global positions, why not add them in for redundancy too?
That's actually what I was
Um,
thinking as well. Like, I think we should always calculate the absolute for these guys, and then also include the local, so that applications that support the local can support these like really intelligent transformations, like you were to use your word of dumb and intelligent. Like, and for apps that support that, great. You know, like modify this one parameter and you can scale. I love the example you gave of the UI, where the UI was able to be scaled by that one because of the parent-child relationships. Like that's a super cool example, but that is a super advanced like layout engine basically. And then for the sake of export, we just like you said, run the calculation to get those absolute coordinates, and then we support a lot of applications that are much simpler, and as well as like human readability of like you could actually just flip through the file and go like, okay, yeah, there's something here, or you could scan through the file from top to bottom to like calculate a hitbox without doing any calculations. You're basically just saying, is there anything between this? Which is kind of interesting. Um,
But I would even agree to put both in the top node standard to have global and local positioning and not have it in relative node extension, but have it all in the core standard. I think
I would love to see. I have to run to another meeting, but I'd love to see like what you
yeah.
mean by that. Like maybe
Right now we have the relative nodes extension where
right.
we define relative positioning, but maybe we
Yep.
should put
Hmm.
both position and size ways, local and global, into one coherent node definition and be
Oh,
done.
it's in the extensions file. Oops. So it would be, where's the example of extensions?
Extension MD, yeah.
Thank you. Sorry. Relative node. So it would be source is the idea of the source node. We would have to move. I mean, yeah, what would we even call that? Like, okay. So it'd be an optional position, optional local position or something like that with an optional source or optional parent or something like that.
Well, if if you have it in main,
If it's on the if it's on the root level node, which is what I understood you to be suggesting.
yeah, or maybe we should add it to the parent-child thing then instead, because as Aaron pointed out, having nested transforms without parent-child is pointless.
Yep.
Yeah, it's kind of at least to me an inherent property of what it means to for be parent and child. Like the expectation in game engines is that um that's what it does. When you make a node a child of another node, it will move when the parent moves.
Mm-hmm. But I think the thing I like about the way we have it is that we've separated the visual from the semantic. So parent-child is a semantic relation, whereas sorry, relative node is actually a visual node. So the relative node impacts how it's displayed, whereas the parent-child, so you can use them independently. You can say these things have semantic relationships between each other, but don't have any visual, like the visual relationship isn't what you would expect from a game engine. And the relative node, you can say, look, like this isn't semantic. This is just purely like, this should calculate it off of that. I don't want to say anything about them being parents and children. It's just, give me a relative coordinate space that I can play in, and I'm just going to put a bunch of nodes in it. And then have them be calculated off of that. So I don't know.
So
I feel like
at least we
I
need to
am-
move scale into relative node.
Yeah, it really, I'm tempted to say we should rename the extension to relative transform, because like it should in theory be all the transform properties, position, rotation, and scale. Size is kind of like intrinsic to it, so I don't think the size needs to be set, because if you want to find the global size, you can take the size property and multiply it by the global scale in the same way that you can find the relative size by taking the size property and the relative scale. So there's already a global and a local, so there's no point in the size being in here. The size is just specified once, but the position, rotation, and scale, these are all transform properties that can be either global or local.
I hear you. Yeah, I think I like it being relative for the sake of being short, but we are specifically saying here that it's relative positioning, and you're right, it's the entire transform stack. It's not just position. In fact, we already have rotation here. So it's like, yeah, position, rotation, scale are the three properties for the relative.
Also, I think we have the position wrong. Right now we have it as an offset, which is just added, but it should be expressed relative to the coordinate system spanned by the parent. That would be much more expressive and useful.
Yeah. Okay, some things to patch up. I gotta run, guys.
That is
Okay.
correct, because if the parent is rotated, then the coordinate system is rotated too. That's what it should be, at least.
Actually, maybe I can do this. Make host. Change host. Boom. All right, there we go. I can leave. You guys can keep talking. Yeah.
All right.
Yeah, so
Thanks,
you're right that it's the spec should specify this, that like if you have a node that's rotated, then like the position of the child, the relative position is going to be relative to the parent's rotation. That's what it should be.
So if we say the parent spans a coordinate system, which is rooted at the 0, 0 of the local coordinate system is the position of the parent. And then what is x and y are the size of the parent. So x goes from 0 to 1, and 1 is the right side of the parent. And y is from top to bottom, and 1 is the bottom of the parent. Is that what's usually done? So it's a stretched coordinate system sometimes?
That is what the anchors use, because they're referring to like percentages of the parent. But
Yeah,
I think
I like that.
usually in like just 2D coordinates, it's not using that system, is actually just doing like a position in logical pixels relative. So, if the parent has a width of 300 and the child is at position of x 200, then that's going to be 2/3 of the way within the parent shape. So it's not 200 times the width of the shape off into the distance.
Okay, so it's just logical pixels, and the parent size is like a clipping on
Yeah.
it.
And if you
Okay.
wanted that 0 to 1 range, then you would use something like the anchors. And the reason for that is because usually if you're I think the expectation is that if you resize the parent and you just like you click on the corner and you drag it, then that's not going to like stretch everything inside with it, right?
Yeah, sometimes it is, sometimes it's not. So maybe both are needed.
I mean, it
So
depends
the
if you're
usual
like
thing
if you're
is,
rescaling or you're like changing it to be bigger.
yeah, that's always not clear. Okay, so but let's say we go with what you just explained me. So the default is like a clipping semantic. And then this anchor is more like the exotic thing. So the default positioning is the clipping. Then what exactly is the size transform affecting? So if I have a local position of 200, as in your example, and my size transform is 2, does that mean my 200 is now a 400?
You mean the scale is of 2?
Yeah, scale, sorry, scale. Yeah.
Then yes. That would be the scale multiplies the child's position in logical pixels, the relative position.
Okay, yeah, that seems logical. Okay.
Yeah, and
Scale
the
multiplies
actual size
size,
property of the
rotation,
parent node is
rotation.
not accounted for unless you're using anchors.
Size of the parent is just clipping. It only depends on what I finally show in the global canvas.
Yeah.
Okay, and then anchors. So if we say we have scale, we have rotation, and then for position, yeah, we still would call it position. And then for the anchors, if you would want to express the position relative to the parent, you would probably say relative position, something like that. And then that goes from 0 to 1. And you can
Perhaps.
either use position or relative position.
The thing about the anchors though
Oh.
that makes this a little more exotic, as you put it, is that you usually are not just specifying the position. With the anchors, you're specifying all corners and sides of the bounds of the thing. So you can say like, you want it, maybe you want the child to be clipped to like the size of the parent or in some way it'll
Ah,
take up half the size or whatever. So it's you actually have a set of numbers from 0 to 1 that is not just a 2D vector, but
so I need to clip at least 2 corners, right? To to
yeah.
some position too. Uh-huh.
Yeah, you can think about it as the 0 to 1 position of like one corner and the opposite corner. But then
Uh-huh.
also with anchors, you usually want to have like offsets as well. So the extension that I made
Ah,
for Godot anchors, which I still need to put it somewhere, I guess. It's just like in my implementation right now. It's 8 total numbers.
uh-huh.
So
It's
it's a lot more complicated than just a
so
two number
it's
vector.
one corner and one offset vector, another corner, another offset vector. Okay.
Yes.
Yeah, makes sense. It's super smart, but it's maybe, yeah, then maybe should live in its own extension
Yeah,
to
that's my thought
feature.
because
Yeah.
uh this is like a feature that I think is not going to be universally implemented and certainly not universally desired. You only want this sometimes.
So then the interplay between these two things would be we have items that have scale, rotation, and position. And then if the anchor extension is used, we know how to recalculate the position if something is resized, but we still have for redundancy this position over there.
Yes, it's completely redundant. So like if you're using the anchor extension, you would need to, of course, export the calculated OCIF properties like the global position and probably throw in the relative node too in case something supports that but not the anchors. And then if you support the anchors, then the anchors takes priority over everything else.
Okay, and now let's try to reconsolidate the position global and local. So currently we use global positions everywhere. And now to make this parent-child thing work, we need local positions. So how do we do the naming? We need to distinguish the two. So if position is always global, then the other one should be named local position, relative position.
The typical naming convention is something along the lines of global or local precision. Um, I can give you two examples from game engines. In Godot, position is local, and then there's a global position for global. In Unity, it's the other way around. Unity has position, which is global, and local position, which is local. And a lot of people are like mad at Unity for doing it that way because in a game engine context, you need the local position all the time. So that means you have the word local in there all the time. But for OCIF, where the expected use case is more so global is useful, it makes sense, I guess, to have OCIF where position is global and then there's a local position for local.
Or should we name the position always global position? Just to avoid some mistakes.
We certainly
this
could do
more-
that. It would increase the size of a file in, bytes, but it can always be compressed. That's like the term global position being present 1,000 times in a file is easily compressible. So I would support that for clarity because I think if somebody's coming at this from a different format where local positions are the default, then having a position property be the global might be surprising. Um, but I'm not going to push for that because I don't want to curse people with bigger files than necessary.
I think if you zip it, it doesn't matter. And if it's sent over the network, it is zipped all the time. So the size, it's more about the typing or the ugliness of the file having longer names. But also I noticed in all our discussions, we had some confusion about local global positions and expectations. So we
Yeah,
can at least propose on the next meetup to use the term global position, just to be clear.
I like that. And this also means at the same time we could do global rotation and global scale as names for those properties to clarify those.
Why are they global? Are they not
Because
local scale and local rotation, and then they compose? Ah, if you multiply like the true rotation that then results.
yeah. So like if a
Ah,
parent is
yeah,
rotated 10 degrees and the child is rotated 10 degrees, then the child's global rotation is 20 degrees.
yeah. Of course, we obviously need that. Okay, but we don't need global and local scale, right? Because scale can only affect children.
If a node has a scale of 2 and a child has a scale of 3, then this child's global scale will be 6, Um, lo local,
I understand, but
yeah.
is that but the real global scale of the outermost node is not used for anything. I mean, global size and global position is and global rotation is useful to display stuff.
Well, if
But
the outermost node has a resource itself, then it's used for that, right? Because it's used for the display of like the image to make the image bigger.
here I'm not sure. My intuition would be to just make the node displaying the image bigger, but by its size. So then it is bigger.
Mm.
So
You know, now that I think about it, more closely, Uh, there's an interesting point here, about the scale and the size. Scale, like usually I think about it as like the purpose of it is to like scale the children with it. And if I'm, making a UI or something in Godot's control nodes, then I usually don't change the scale and I will just change size instead. And if it's something permanent, I'll just resize the children to be bigger because it's easier to just not deal with scale if you don't need it. So that if it raises a point, if we're defining these things global anyway, then why do we even need
do we
like
need scale at all?
yeah, we don't need
Yeah,
scale at all because if you want to kind of like bake um a scaled object to an OCIF, you can just like compute the global size of everything and then write that and then have everything be a scale of 1 and you can just essentially get rid of scale. You don't need it anymore.
yeah, that is a UI thing. That the UI
You
changes
can
the width and height of the elements.
you can
That's what you mean,
calculate
I
the
think.
local sizes. and don't need scale. And from the local size, you can compute the global size as well. But if you zoom in a lot, you would rely on the local size and local position to display things correctly.
But if everything is a scale of 1, so if there's no scale, then the concept of global size and local size are the same. 'Cause if you have,
Yeah, but
a child
don't,
node with a
yeah,
scale of a child node with a
now I
size of
get it.
100 by 100, it doesn't matter what you do to the parent. It's gonna be always that size. You can't scale the parent because we just said you can't. If it's always a scale of 1, then the sizes are that's just the size, global or and local both.
So then to work around limits of doubles, we need to,
Honestly, man, I don't know
I get
about working
confused.
around the limits of doubles. I think if doubles are posing a problem for you, then you need to just go implement quadruples. Like, it's a thing. There's an IEEE standard for it.
So in OCIF, we just don't have any scale factors, and you
Yeah.
write your position into the position, and that's it.
Yeah, we straight up just don't need scale if everything is going to be global because there's no point. Um, the scale is the only use it has is with the parent-child relationship, as far as I know. Because if you want to make the node itself bigger, you just make the size bigger. And if you want to make the children bigger, you could always bake that. You know, the app that's doing the scaling can bake that. But it has no separate meaning. If you're not going to um, have the local transform be the main transform. If we're just doing global everything, then just do scale. I mean, do no scale and have only size.
And what about rotation? Does it still make sense to have global and local rotation? Seems to
Yeah,
be.
it does make sense to do that, yes. Um, because like we're talking about replacing, scale with only the size because that determines how big things are. But the rotation is a whole different thing, and that needs to be kept. So, yeah.
So we have only position, which is global, only size, which is global. Then for rotation, we distinguish global rotation, local rotation. Then we have the anchor extension, maybe to really smartly, relatively position things.
So when you said we have size, which is global, um I think you already know this, but I'll just state again that if we don't have scale, then there's only one size. So it's both global and local. It's both.
Yeah, we only have one size. Yeah, yeah. But each item has a different size, maybe.
Yes. Yeah, yeah,
Yeah,
yeah. I mean, each item only has one size defined.
yeah. And then currently we have this relative node extension, which uses an offset to place things, which is quite redundant to just use a group and say, yeah, these should also move together. So relative node becomes irrelevant and scale needs to go. That's sort of
Yeah.
the consensus. And the rotation needs to be distinguished between global and local. So these
Yeah.
are the three results.
They're good results.
Good. Yeah, and they require some spec changes for our candidate recommendation, I see.
Yeah. This is like one of the unforeseen things that I'm like, wait, don't push it out yet. We're still talking about this.
Maybe we have everything resolved until May 28th. Okay, I can add these changes to the spec in a PR, but it's quite clear how to. Yeah, that was very enlightening for me. Thank you.
Hmm.
I'm not sure we are still recording or not. I don't see any recording
The
things.
But before we completely close out on that, I do want to mention one other thing. So we don't need scale at all if we have size as, you know, the definitive factor for how big something is. But is it possible that somebody will have something in OCIF that is not needs to be scaled somehow, but it doesn't use size? I can't. I'm not really sure. Like in, you know, in a 3D model we have like meshes, and the scale will affect the positions of the vertices. So the model doesn't really have a size to be bounded by. It just kind of is these vertices multiplied by the transform. Um, but is is that a thing that is there anything like that in OCIF that would make use of scale in that way? I mean, it wouldn't make sense for like images and stuff. And I guess text, you know, you could have text can define just a font size as needed, right?
Text is its own can of worms. How you want to have the text being zoomed or not when you zoom around. So your mesh example, can we find that in a map? So for a mesh, if we would embed the mesh only using global positions, then the import of such a mesh would be a pain, because then you would have to recalculate local offsets or somehow. Do we
I
have
mean,
such use case in a
you could
map?
easily bake the scale. That's like that's actually something that is recommended often because some tools, you know, don't support scale, and so it's common to bake things occasionally. Um, one
I think it's
use
fine to have
one use
only
case
global size and
of
position.
one use case of like runtime scaling that I can think of is with like um something like a game that uses FBX files where the games usually use like meters and FBX files are centimeters, and so you just import the file as is and then you give it a transform to scale everything down by 100. Um, but that's like that doesn't apply to OCIF at all. Um, I think usually you don't even need scale in 3D games.
Okay, what about nested maps then? So we have one OCR file having only global positions and another OCR file having only global positions. And now I import that one into one of these rectangles over here. I need some kind of transform to put that into here, right?
Right, that's why I say that the only way I can imagine it is relative to the root of the document. So if you import it over here or whatever, then that's going to take the over here position and just um, adds that to the global position of every single node in there, essentially.
But this
That's at
is
least
never what you want, because it would just clip everything out and just, if you have two maps being 1,000 by 1,000 pixels and import the second one to the first one, then you would only see a tiny fraction of it. And only if you resize that node, you then see the invisible stuff.
I'm a little bit
So,
confused as to your example here.
okay, let's say these are my two maps.
Yeah.
And now I want to, this one being imported in a tiny rectangle here, so that later if I zoom in, I see it full. But if I
Oh,
just
yeah.
import it, the coordinates would just either overlap completely or being relative, and then I would just clip most of my second canvas. So what I really
Right.
want is to say, if I nest a canvas, I want it, yeah, to be zoomed full screen or full rectangle where I import it.
So the scaling could be done by the importer or whatever, or the runtime, and a whole file like that could be baked to OCIF. But that is a good point. If we have an OCIF file using another OCIF file as a resource, is that something that we need scale for? Because
Maybe not, as you pointed out, maybe, I mean, if we have a rectangle that shows a PNG file, we also sort of auto scale it to fit it into that rectangle. So what, I mean, at least that's what's happening in my head. We never talked about it.
But
What is
but
the coordinate system for the PNG here?
but here's the thing with that. If you have so if you have, say, like some node has some size and you
Yeah.
want to have this node's resource be another OCIF file, then you need to somehow scale that OCIF file into this rectangle, which means that whether it's implicit or explicit, you're saying that the OCIF file has a size. And that's
Right.
something that we don't do. So that's
Yeah.
tricky. So maybe we do need scale for that case, unless we could find another solution.
We need size for the OCIF file, which is
Yeah.
just the bounding box of all content boxes. Trivially to compute because we have global positions and sizes anyway. So we just put all corners to an index and then we get the size. And this size implicitly defines the transform that's required to, but there are some caveats about the aspect ratio because you don't want your aspect ratio to be messed up. So you say you fit the longest or shortest side to define the transform. I mean, how do we display a PNG if we have a box 100 by 200 by 100? And we say we want to display PNG 1000 by 1000. That PNG needs to be rescaled, but what is it showing? Is it showing like the upper half of the PNG? Or is it showing the full PNG and having white boxes on the side? We need to define that. It's quite crucial, actually.
Absolutely, that does need to be defined. One
In
analogy.
CSS, you can define that with object. What's it called? There's this property for it. You can say it needs to cover or it needs to be contained, and then the image behaves differently. So,
Okay. So there's a CSS property that's like that. Do you know how it's called?
I use it as of the object fit. Object fit.
Object fit. So we should.
Also for background, that's the same. Something.
Okay,
different.
that's perfect. That's exactly what we need. So if we add size to the canvas, which can also be computed, but we can also add it as it's our nature to always add redundancy. And then we have also an object fit when we import any kind of resource, actually. We need this for any resource. Then we can just reuse that for importing OCIF files too. And
so when it comes to defining this, my expectation is that the default behavior or whatever would be to stretch like a PNG. But
stretch.
you know, like it ends up looking like all squished and stuff in one direction. But then for an OCIF file, there's more interesting behaviors that we can do here, including ones that kind of like reveal additional space on the side, I guess is what you could put it. The way that this works in game engines with cameras is that you define a certain direction as the keep direction, the keep aspect direction. So for example, in Godot, you have the camera and it has by default keep height. So you define the field of view of the camera vertically, and then if you make the window bigger, you can just see more on the. If you make the window wider, you just see more on the sides. The you could also do it the other way though. You could have it keep the width, and then you like make the window taller, and it lets you see more up and down direction. And vice versa for shrinking it. You'll just see less if you shrink it in those specific directions.
I have to go, by the way. Yeah.
Okay, yeah.
See you next time.
Thanks for being here. Have a great
you as well.
weeks. See you.
See you. Bye-bye.
So now we battled all the issues. Yeah, we need something like object fit or keep aspect or a mix of the two concepts. that's utterly missing from the current spec to define how to display a resource.
Yeah, so yeah, if you have like a square PNG and you want to display it in a wide box, what do you
Yeah,
do?
what's
It doesn't
happening?
say.
Yeah, yeah, yeah. And we just need a property to state that, and we need a reasonable default behavior. Yeah, that makes sense.
Mm-hmm.
Wow, I think we resolved a ton of issues today and even found new ones,
Yeah.
which we also resolved. Yeah, now
I-
I'm
One thing I should briefly note is that if you have things that get like squished or stretched or whatever, then you do what that effectively means is that the contents are non-uniformly scaled. And non-uniform scales means that the transformation is not what's called conformal anymore, and this can mess up a lot of calculations that you want to do. So like for example, if you're trying to do calculations on a circle and you stretch the circle, it's not a circle anymore, it's an ellipse. And
yeah.
an ellipse can be much harder to calculate things for. So but if you uniformly scale a circle, it's still a circle. So some things can get really more tricky if you allow if you do non-uniform scale. So a lot of engines, even though they have, you know, the X, Y, and sometimes Z scale properties, they usually say like, oh, you should do the uniform scale and only do the non-uniform if you really need it for something, because it's like it's gonna mess up things.
So our default should maybe not be the stretch option then.
It's maybe okay for like an image. And I don't have a complete list of everything that this messes up, but I know it'll completely mess up like a physics engine, for example. So if you wanted to have stuff in your canvas like move around with physics and bump into things, that's going to completely explode if you have non-uniform scales.
Hmm. Um, well, if we have it as a default setting to add stuff on the side or on the top, so just make it as big as possible as it fits into that box and then add white space. Then for debugging and import purposes, you always see what you have, and sometimes you see it's too small, and then you can resize stuff. That seems to be for OCIF maybe the most useful default. So it doesn't squish, so it doesn't mess up math, and there's no hidden stuff. You always see all your stuff, although sometimes a bit small. I think that's my favorite for this reason.
All right, makes sense. Um, well, I think that wraps it up. Yeah,
So now we'll have dinner.
yeah. It's it's
At
it's
least in
it's
my
a
time
morning
zone.
here.
It's almost 8 o'clock here, PM. So I'm ready for
Yeah.
dinner now. Yeah, wow, that was one of the most productive sessions we ever had.
Yeah.
So thank you a lot.
Hmm. And even if we keep scale, we need to like be very clear about like what it's, how to use it, what it's for, and if we want to replace it by size, we have to have a very good definition of like the keep aspect stuff. So I guess those are like the two ending notes or whatever.
Yeah. All right.
All right, bye.
So for you, have a great day. And for me, I'm done. See you next time. Bye bye.